So is the screen visible?
Yes, sir,
Yes, sir,
visible.
visible.
Okay. So my name is Nitin Tomar and I'm a third year PhD student in the Department of Mathematics at IIT Bombay. I welcome you all in the discussion of third assignment of the NPTEL MA 57 course, and this assignment is related to the power series. So let us recall what is a power series. You must have seen this. So again, those who are new, so there are some MSQ questions. For example, 3.1 is an MSQ question, which means multiple select questions. So it may have more than one correct options. So the correct options have been explained in blue color and the false option has been explained in the red color. Okay. So let's start the assignment. If at any point you something is not clear, please stop. So the power series expansion of a complex analytic function will be denoted by this. This we all know that what do we mean by a power series expansion of a complex analytic function about a point w. Now why does this exist? Because f is we are considering analytic functions, and every analytic function at a if a function is analytic at a point w, then it will have a power series expansion in some neighborhood of w, let's say z minus w is some epsilon. It doesn't matter. I mean, locally it will have a power series expansion. Now one thing that you need to observe is that this coefficient term an, this depends on w. As soon as you change your w, your coefficients will change. Okay. So with this we start our first question. So you consider a polynomial. Fz is a polynomial of degree n. Fz is a polynomial of degree n. Now which of the following options are true? F has a power series expansion on every point. Can anyone tell me? Okay, the answers are visible, but everyone should know that a polynomial is an entire function, right? It is differentiable. So it is an entire function. It is differentiable at every point of complex plane. Hence, it is entire. And every entire function admits a power series expansion around every point. Okay. Is this clear? The first option? Okay. Now what can we say about the radius of convergence of power series of function f? So technically, what is the radius of convergence for an analytic function? Can anyone tell? What is the radius of convergence? See, this is more like a discussion class. Okay, let's have an active participation to learn what we are discussing. So can anyone have some rough idea what is radius of convergence? Okay, let me give you a very brief idea because
Generally,
Generally,
we
we
take
take
it
it
for
for
convex
convex
lens
lens
or
or
lenses, no,
lenses, no,
sir?
sir?
convex lenses.
Radius of
Radius of
convergence.
convergence.
No, we are not talking about physical phenomena here. We are talking about the radius of convergence of the power series.
Power
Power
series,
series,
okay.
okay.
Yeah. Okay. Okay. So yes, but this is very good. Please speak. So if f is an analytic function in omega, omega is a domain in C. Okay. F is and this function is analytic, and this omega is a domain. Okay. Now we know that given w, if I take any point w in omega, because it is analytic, fz can be written as z minus w power n right? This you know, right? W minus, let's say, z in some radius r, and such that this domain is contained in this disk is contained in omega, or maybe not, but okay, let's see. So this power series, what we are trying to say, let's say this is our complex plane and this is our domain omega. Now let's say W is some point here. So what we are saying, that there exists a disk of radius r, right? This disk of radius r, in which f has this representation, in which f has this representation. Yes or no?
Yes, sir.
Yes, sir.
Now
Now
understood.
understood. Yes, yes.
Yeah. So now radius of convergence is actually the maximum possible radius of such disk. Are you getting my point? For example, okay, let me start with one example. Now, you know that this series converges, right? In mod z less than 1. This you know, right?
Yes.
Yes.
And this function in this can be represented at 1 upon 1 minus z. Yes or no?
Yes, sir.
Yes, sir.
Yes.
Yes.
Now, just so if I consider this series, see what is this disk? This is nothing but disk centered at 0 of radius 1, right?
Yes.
Yes.
Now, now the question is, how far can I go? So this is my radius 1. So can I move further to such that this power series expansion still holds? This is 0. Say for example, you know that if you take some point bound, let's say 1. So does this series converges at 1 at z equal to 1?
Not.
No.
No.
No,
No,
sir.
sir.
No.
No,
No.
right? So which means we cannot go further than this, what we have already, right?
Yes.
I mean, I cannot increase the size of the disk such that in this disk, this series Zn converges, because if I increase the size, one will be there, right? The point one will be
Yes.
there,
Yes.
and at one it diverges.
Yes.
So
Yes.
Singularity.
Singularity.
exactly, so one is the radius of convergence for this power series. By this, what I mean, that positive real number 1 is the maximum length or maximum radius of disk centered at 0 in which this power series is well defined and converges. Is this clear?
Clear, sir.
Clear, sir.
Now.
Now.
Yeah, okay. So this question is about the radius of convergence. Now if a function is entire, okay, now the function is entire. So what do we mean by entire function? Can anyone tell? It is analytic everywhere, right? What is an entire function? It is nothing but analytic in the entire complex plane. Yes or no?
Continuously
Continuously
differentiable,
differentiable,
sir.
sir.
Yeah, continuously differentiable in the entire complex plane, which will imply analyticity, right? And vice versa.
Yes.
Yes.
Yes, sir.
Yes. Yes.
Okay. So if you start at 0 and you take any disk, right? So this, I'm talking about this f is an entire function. So this f is analytic here also, right? Because it is entire in complex plane, so it is entire in this part also, right?
Sir, one
Sir, one
doubt, sir.
doubt, sir.
Are
Are
all
all
analytical
analytical
functions are
functions are
entire
entire
functions?
functions?
No. For example, 1 upon 1 minus z, okay? It is
Okay.
analytic in mod z less than 1, okay? But
Okay.
Okay.
it is not entire,
Oh,
Oh,
okay.
okay.
okay? Yeah, yeah.
Uh,
So if a function is entire, what should be the radius of convergence?
Less
Less
than
than
one
one
per
per
unit
unit
circle.
circle.
No.
Infinite,
Infinite,
bro.
bro.
Yes, please.
Radius of
Radius of
convergence is
convergence is
infinite.
infinite.
Exactly. The radius of convergence should be infinite. Why? Because you can expand this disk as large as possible, right? Because it is an entire function.
Yes, sir.
Okay. So yeah. Okay. So the radius of convergence of power series of f around any point is infinity, because a polynomial function is an entire function, right? So its radius of convergence should be infinite. Now the question is, third question is, there are only finitely many w such that a naught is 0 in the power series expansion of f around w. So recall that how are we denoting, the notations are important. Around w, this z minus wn an, right? This is the power series expansion of f around w. Is it fine? Now what do we have to collect? We have to look for all those w such that a naught is 0. Now what if a naught is 0? Okay, so we are considering this power series. Now because it is a polynomial, so it won't have infinity here, right? Or let's say, because f is a polynomial of degree n, we can use another variable, let's say j going from 0 to n, because remember we are starting with a polynomial of degree n. Okay, so in the power
J
series,
should start from 1 now, sir.
huh, sorry,
J should start from 1 now.
yeah, okay, it's fine, yeah, it doesn't matter, but yeah, it's fine because we have separated the constant term. Okay,
Yes.
now when is a not 0? Can anyone tell me? See, we have to look,
When
a naught is 0 if and only if f of w is 0. Am I correct? See, you put w here.
Yes, sir. Correct. Correct.
Correct, yes. Now f is a polynomial, right?
yes, yes.
Now, and w, so a naught is 0 if and only if w is a, actually we should denote it as a naught of w, right? Because it depends on w. Is this correct? That's how it
Sure,
will
sir.
make more sense. If and only if w is root of f. Now, what is f? F is a polynomial, remember. Now, how many roots a polynomial can have?
It depends on the order, no, sir.
Yeah. So, but they will be finite, right?
Yes, yes,
Yeah.
fine.
So, at most, which means w is a root of f, which means number of w, or what should I say? Which implies that there exists only finitely many such w. Am I correct?
Yes.
So, is this option correct? This
There
option
are
is correct, right? Because there are only,
finitely
we
many.
just proved that there are only finitely many w's for which a naught of w is 0.
Okay,
Because
sir.
when is a naught of w is 0? If and only if w is a root of the polynomial f, and a polynomial can have at most roots as many as its degree, right?
Yes,
Yes,
sir.
sir.
And which theorem is this? Can anyone tell me? This is precisely the fundamental theorem of algebra, right? Anyway, so third option is correct. Now let's move on to the fourth question. See, this is, today I'm getting a very positive vibe because all of you are participating. And this is such a good thing. We are here to learn, we are here to discuss. It should not be like I just come here and tell you some solutions and you go back, right? You can ask me doubts and we can discuss. This is more like a discussion session. And I really appreciate you participating. Now, read the question carefully. There are only finitely many w's such that n plus 2 is not 0 in the power series expansion of f around w. Now because f is a polynomial, we will have this power series expansion, right? We also saw this in the third part. Is this correct up until now?
Sure, sir. Okay.
Yeah. Now what does an plus 2 represent? An plus 2 is nothing but the coefficient
Even
of
even quotients.
coefficient of z n plus 2, right? Oh sorry, z
Yes.
z minus w n plus 2 in this power series expansion.
N plus 2.
Now what is f? F is a polynomial of degree n, remember that. So will it have n plus 2 term? I mean this is a polynomial. F is a polynomial of degree n. This is given. Now can it have an plus 2 as non-zero? If it has an plus 2 as non-zero, which means from here this will have zn plus 2 something something, right?
It should terminate at N only, no, sir?
Exactly. So if it should, why? Because it is a polynomial of degree n, so the term should terminate precisely at nth stage, starting from 0. I mean 0 1 2 3 up to n. So n plus 1 n plus 2 up until after that everything will be 0, right?
Yes.
So this an plus 2 will be 0, right? Always.
Always. Okay.
Yeah. So now we have concluded this. So what are the points where an plus 2 is not 0? This is an empty set, right?
Yes.
So empty set is a finite set, right?
Yes, sir. Yes.
So this option is correct, right?
Okay, sir.
Yeah. For example, now if I change the question, instead of this, I ask this an plus 2 is 0.
Again, we have finite only W number of.
No. For every w you choose power series expansion, an plus 2 will always be 0. So there will be infinitely many, right?
W.
What I'm trying to say, you change this condition by, you change this question by n plus 2 equal to 0. We have concluded that n plus 2 is always 0, no matter what w you choose and what power series you make around that w. N plus 2 will always be 0 because f is a polynomial of degree n.
Yes, yes. It doesn't affect exactly.
Exactly. So then this option will be false. I mean, if you replace this condition. Okay. Now let's go to the fifth question. So read the fifth question, fifth part, sorry. Suppose that f has all its roots inside C and does not have any repeated roots. Then the number of points w such that the constant term of the power series around w equals 0 is n. So you remember that we so again and again we are using the third part discussion. Okay. So f is a power, f will have some power series expansion, right, around w, because we have to consider the power series around w. For example, here you read, you choose w first and then make a power series, construct a power series around w. So this is our power series, right? Now because f is a polynomial of degree n, it will terminate, it will not go to the infinity. This series will terminate at stage n. Right or wrong? Are you with me? Yeah, okay, Prakash. Thank you. So
Sir, in
we'll have.
earlier case, sir, in earlier case,
Mm-hmm.
in fourth statement,
Mm-hmm.
we have changed from infinity to n, no, sir,
Yes.
summation.
Yes.
So then the roots will be finite only, no, sir. How it will be infinite?
No. When n, no, in the fourth question, n plus 2 is not the root. Na? N plus 2 is the coefficient of z minus w n plus 2.
So that's okay, sir. But finite number of points, sir.
No, no, you take no, no, no. In all these three questions, what you are doing, you are choosing a point W first, then you are
Okay.
making a power series around W.
Yes.
Okay, and in so this is the power series, and in that power series, you will have n plus 2 term, right? N plus 2, actually it will depend on W. You change W, your n plus 2 W will change. So it is a function of W.
Oh.
Okay. Now the question in the fourth was whether or not this will be 0 for finitely many points. And we saw that it doesn't matter what W you start with, n plus 2 term will not be there in the power series. Because f is a polynomial of degree n. So no n plus 2 term will be there. Hence, for
Yes.
every w,
Yes.
n plus 2 will be 0 for all w. Okay.
Okay.
Now, for all w, n plus 2 is 0, which means the set of w's for which n plus 2 is non-zero is empty set, right?
Okay.
So, which is a finite set, right?
Okay.
Yeah, so this was the question.
Okay,
Actually,
sir.
you may write it like this, like all those. So we have to check the cardinality. This hashtag is a symbol of cardinality. So this W contained in C, you have to check the cardinality of set such that n plus 2 of W is 0. So you please write this, otherwise you'll get confused. And we saw that in this case it is infinite. I mean, this set turns out to be the entire complex plane. You please just write this one line wherever you are solving your assignment, and this might help. Now, similar thing we have to do for the fourth question. Okay. So in the fourth question, what we have to do, we have to look for the set W in C. You choose a point W, you make the power series, and there will be a constant term, right? A naught, and we have to look for this set. Now, in the first part, we saw that it is nothing but this set is same as f of w is 0, right? In the third part, you remember this, right? Now, which means w is a root of f, and it has been given that f has no repeated roots. So how many w will satisfy this condition? Precisely n, right? Because it has no repeated roots. So this option is correct. Is this clear?
Yes, sir. Sir.
Okay.
Clear.
Now, sixth option you check, like because we have discussed it so many times. So this is one particular polynomial you have been given, and you have been asked, like, you expand it around the point 4i. Let's say we expand it around 4i, and you have to look, so around 4i, how will it look like? It will look like an z minus 4i, right? And where this n goes to 1 to 3, because 3 is the degree. This n goes to 1 to 3. Now the constant term is a naught, right? So the question is the constant term in the power series of f about the point 4i equals 0. Okay. Now when is this constant term equal to 0? Precisely at 4 iota, right?
Yes.
So a naught is 0 if and only 4 iota is 0. But you check 4 of iota is not 0. Okay. You please check this. This is just calculation. So this option will be false. Okay, now let's move to the second question. And second question is a bit more interesting. So you have this power series. So this is a power series expansion around z equal to 0. Okay, and it has been given that it has some positive radius of convergence. Now, which of the following statements are true? If ai equal to aj, which means all the coefficients are equal. So if all the coefficients are equal, then f is uniquely determined by f0, which means uniquely determined means if I know f0, then I know complete f. Okay, so let's check. So this is my power series expansion, right? And if every coefficient is equal, I can pull a naught common. I can take a naught out.
Yes,
And
sir.
if you put z equal to 0, what does it give? It will give you f of 0 is a naught, because when you put z equal to 0, f of 0 will be a naught 1 plus 0, because it starts from 1 here, so z plus z square blah blah blah, so it will be precisely a naught. Now you replace a naught by f0, you will get this. So now you know that if you know f of 0, you know complete f, right? Because this part is fixed, the bracket is fixed. Is it clear?
Yes, sir. Now got me.
Yeah, okay. Now again the same condition is given, all the coefficients are equal, and now this time they are telling us that a naught is not 0, and they are asking whether or not the radius of convergence is 1. So using part 1 we have this. Now what should be the radius of convergence for this series? It should be the same as the series given in the bracket, right? Yes or no? Because
How,
it is
sir?
just huh.
How, sir? Tell me. How, sir?
Okay, so let's say this function is gz. Okay, do you know the formula for radius of convergence?
Don't know, sir. I have not followed the video, sir, actually.
Okay, okay, but okay, so there is a formula for radius of convergence. Okay, so it is r is given by this lim an plus 1 lim sup of this. Okay, now where this r, okay, rf I am denoting by radius of convergence of f. Okay, so all of them are equal, right? An and an plus 1, they all are equal for f, right? This is given.
Yes.
So this is a constant sequence, so its limit will be 1. Now what is r of g? R of g, it is again, like, okay, it's bn plus bn plus 1. Now where an, what is bn? Here, what if you write it as bn zn, n going from 0 to infinity, so you know that bn is 1 for every n, right? By comparing, so it will be lim sup 1 by 1, which is 1, right? Is this correct? So you have proved it, right? I mean, okay, directly you could apply the formula and prove it. Is this clear? Okay, so the radius of convergence is indeed 1. Now the question is, if this coefficient has this relation, an is n plus 1 times an plus 1, then the derivative is f is itself, which means f of z, you have to prove or disprove, is f prime z. Yeah. So let's start with proving, because it is true. So suppose f has this power series expansion. Okay. Now we are no longer given that these coefficients are equal, but we are giving that there is one relation. So this relation is there. Now in the region of convergence, you know that you can differentiate term by term. So when you differentiate a naught, it will become 0 because it is a constant term. And this a n z n, what will be the derivative? What will be the derivative? It will be n a n z n minus 1, right?
Yes.
So do you agree with this, what I have written?
Yes, sir.
Yes, okay. Now see, I am doing from coordinate change. So from here to here, how do we reach? You increase n by 1. So you are replacing n by n plus 1. So this n will become n plus 1. This an will become an plus 1. and this Zn minus 1 will become Zn. Is this clear?
Yes, sir.
Now here n was starting from 1, but when you're shifting by adding 1, then it should start from 0. Okay, so this is just the coordinate change. Now you are given that this term is precisely an, so you will get that f prime z is actually summation an zn, which is f of z precisely. Is this clear? If you have any doubt, then please ask. Okay, I think this is clear. Thank you, Prakash. You have been really helpful. Thank you. Now the question is, so what is f of z? F of z was a naught plus summation a n z n, 1 goes to infinity. And from this we have constructed g of z by just squaring the coefficients. This is clear, right? We are just squaring the coefficients. So if the radius of convergence is 2, then does this mean the radius of convergence of g is root 2? What do you think? If you're squaring, what does your gut say? What is your intuition? How does radius of convergence should change?
It should also be in squares only,
Exactly,
but it's
exactly.
surprising.
No, it's not. Yeah, we'll see the proof how. Okay. So I'll change color because otherwise it will be too red. It's like we are killing something. Yeah, we are killing the problem. That is one thing. Yes. So let's say gz is this, right? Gz is the square. Okay. Just a minute. I think the screen froze. Yeah, it's visible now. So can I write it as bnzn? Because I'll just choose my bn to be an square. Because otherwise, I want to apply radius of convergence formula. Okay. So the radius of convergence of G, denoted by R of G, it has this formula, right? You all know this. You should all know this. Lim sup of the coefficients of the power in the power series of G. And what are the coefficients? These are Bn. But what is Bn? Bn is n square, right? Yes, Prakash, this is Cauchy root test, nth root test. Yes. Now this 2 you can take out, right? And because everything is positive, this square you can completely take out. And then what will you be left with? You'll be left with lim sup mod n power 1 by n square, right? And what is this precisely? Radius of convergence of f and square. So if radius of convergence of f is 2, then this discussion tells us that radius of convergence of g should be 4. Is this clear?
Yes, yes.
No, if you have any doubt, then please ask. We have just applied the formula for the radius of convergence. So it doesn't matter 2. 2 has no role to play here. Had it been 3, 4, 5, or some alpha, the radius of convergence will change accordingly. Okay. Now the question is the fifth part. So hence it is false. The fourth option is false. Now the fifth is, if the radius of convergence equals to 1, then power series of f around the point half has also radius of convergence equal to 1. Please, yes, some of you have your mic open. Please mute them because it is creating disturbance to other students. Thank you, Ravi Shankar. Yes. So, what do you think? Is this true? So, remember, F was this summation a n z n. So this was the power series expansion around 0, and it has radius of convergence 1. So which means you can go as far as 1 without being any trouble, right? This might look like oval, but I'm trying to draw circle. Okay. Oh, okay. Let me draw here. Yeah, this is good. So this is 0 and this radius is 1. So from 0 you are going to radius of you're having radius of convergence 1, and after that it diverges by the definition of the radius of convergence. So what do you think? So half is here. So how far can you go to from f? How far can you go from f without being in trouble? It should be half, right? Because you cannot cross this boundary. So is this option correct, that around the point half you'll have the radius of convergence equal to 1? It is wrong, right? I mean, it should be false. Does everyone get this, what I'm trying to say?
Okay,
Okay,
sir.
sir.
Okay. So one example has been given here, okay? Now let's compute the third question. The radius of convergence of this series, the radius of convergence of of the following power series around the point 7 by 3 is capital R, okay? And then we have to evaluate 3R. So it is around 7 by 3, so make it look like around 7 by 3, okay? So what do we do? So 3 is z minus 7n. You take 3 common, and it will become z minus 7 by 3 power n and 3 power n. Right? Now it looks like it is around 7 by 3. So this step is clear, right? Is this step clear? Okay. There is nothing. This is some basic algebra that I have done. I mean, it's not even that. Yeah. Now you apply the radius of convergence formula. What is the radius of convergence? Is 1 by r equal to lim sup of the coefficient power 1 by n. So the coefficients are 3n by n. Okay. Now when you apply the root test, 3n by n power 1 by n, it will be just 3 by n power 1 by n. And we know that its limit should be 3 as n goes to infinity. Why? Because n power 1 by n is 1 as n goes to infinity. So 1 by r is 3. So what is 3r? 3r is 1, right? So this is clear. Okay. So the fourth question is also about this radius of convergence. So if p is a polynomial, then what is the radius of convergence of the following power series? Now the power series might look very bad, but see, what does it say? It is 10 plus p1 z. Okay. p2 by 2 factorial. 2 factorial is 2, right? So z2, then p3 by 3 factorial, and 3 factorial is 6, z6, and some so on and so forth. Okay. Now you see that there is, so z power n factorial means that in between the terms are 0. So for example, there will be no z cube term, there will be no z4 term, there will be no z5 term. Basically anything which cannot be written as factorial of naturals, their coefficients will be 0. So we can rewrite the series as this. Just for the sake of comfort, we are writing this series where these coefficients are, if m is n factorial, it should be pn by n factorial, this am, right? And otherwise it should be 0. Is this clear? up until now? Just give me a thumbs up, yes or no, or thumbs down.
Okay, sir.
Okay, sir.
Correct.
Correct.
Right.
Right.
So now you again apply the this root formula and you will get your result. Okay. So this answer will be 1. So 1 by r will turn out to be 1. So this will imply r equal to 1. So much like we did in the previous question. Okay. So now let's go to fifth question, which is again we are in the MSQ zone. Now these questions are about the holomorphicity or the analyticity. So suppose that f is a holomorphic function defined on a domain omega whose image is contained in a straight line. Then f is 0. Should f be 0? You just take constant function 1, right? So constant function 1 is a holomorphic function. And what is the image? Image is just the straight line x equal to 1, right? I mean, if this is your domain and f acts like this, so domain is denoted by x plus iota y, so I'm writing xy. Range is denoted by u plus f, it's u plus iota y, right? So this is u axis, this is v axis. Now what do? You just take constant function 1, everything goes to 1. Ravi, it is holomorphic. Okay, holomorphic means analytic, and homomorphic is no such term. Either it is homeomorphism or homeomorphic, or it is homomorphism, which you learn in topology and algebra respectively. So fz equal to 1, everything goes to 1, which means this line, right? So I mean this, I want it to be straight, yeah. So this line. So this option is false. It can be not 0. Now go to the second question. Same question. If f is a holomorphic function defined on a domain whose image is contained in straight line, then f has to be constant. Regular functions are something different, Prakash. Have you seen the lecture videos? Ah, okay. So basically, okay, let me tell about the holomorphic functions in a quick review, because I cannot complete the topic here. If you have a domain, a function f in omega, complex valued function, and this is omega is a domain in C. A function f is said to be holomorphic at a point w in omega if, let's say, this is w. If there exists some neighborhood of w contained in omega in which f is differentiable, then we say f is analytic at w. And if this property holds for every w in omega, then we say that f is holomorphic in omega. And a holomorphic function has many properties, one of them being is the Cauchy-Riemann equation. If a function is holomorphic on the domain, then it will satisfy Cauchy-Riemann equation. But anyway, so f is the image of f is contained in a straight line, then f is a constant. This we have to prove. So we know that when we are in R2, what is the image of line? Y equal to mx plus c, right? Where this m is the slope and c is the translation. So here in the complex plane, the align is given by this same thing. Here we are replacing x by r, because x is we reserve for z equal to x plus iota y for the real part of z. So we are changing it by r. Okay. So a line in the complex plane is given by this set. Line is a set, right? Line is the image set of certain points. So this is mr plus c, where r belongs to the real number and m and c are some complex numbers with m not equal to 0. Because if m is equal to 0, only c will remain, and it will be a point, and we are dealing with line. Okay. Now let us suppose that f is contained in some line. Then fz must be of this form, right? M of fz must be mr plus c. But this r now depends on z. You change your z, your r might change. So you because m is not 0, we can have this. You just, so from here you will get that c is nothing but f z minus m r z, and you divide everything by m, and you will get that r of z is fz by m minus c by m. Now see this r, remember from the, so f is holomorphic, and any translation of holomorphic functions or scales after scaling, they remain holomorphic. So this r is holomorphic, right? Why? Because f is holomorphic, and it is real valued, because it we are starting with the line, these coefficients are coming from real. So this r of z, this is nothing but a holomorphic real valued function. Now if I have a holomorphic real valued function, okay, I want to prove something. Okay, let's say f in omega to r is real valued, it is real valued holomorphic function. Okay, so if it is real valued, then we know that this u plus iota v, this v will be 0, right? Because f is real valued. Because f is real valued, so this v will be 0. Now what does Cauchy-Riemann says? Ux equal to vy and uy equal to minus vx. This is Cauchy-Riemann equation. Uy equal to minus vx. Because v is 0, so everything will be 0. And what is the derivative? Derivative is ux plus, can anyone tell me the derivative? Okay, it is ux plus iota vx, and this will be 0. Yes, yes, please speak. And the derivative is 0 on a open and connected set. Remember, omega is a domain. Now what does this mean? That f is constant, right? So any real valued holomorphic function on a domain is constant. And what we have proved here, that this just a minute, let me delete all this. So this rz is a real valued holomorphic function, so it has to be constant, right? This r has to be a constant function. Now if r is a constant function, then this f has to be constant function, right? Because fz was what? mrz plus c. If this is constant for all z, let's say this is some alpha, so m is constant, c is constant, and alpha is also constant, so everything is constant. So this option is true. So is this clear? Yes. Now the same thing you can do for the next question. It says f is holomorphic in a domain with constant modulus. Then f is also constant. You must have seen this in your lecture slides, right? Or if not, then quickly let's go through the proof. We are given that mod f is constant, okay? Now remember that, okay, let me use some different shade. So you can write f as u plus iota v, right? Now mod f will be, by definition, it will be u square plus v square, and this is constant. So if u square plus v square is constant, let's say some c, then what will be its derivative with respect to x? Because u and v are function of x, it will be 0, right? Because u square plus v square is constant. and similarly with respect to y also it will be constant. So we have this. But what is del u by del by u square plus v square partial derivative with respect to x? It is 2u ux plus 2v vx equal to 0, right? 2 you can cancel, I mean 2 you can shift to the other side, and this will imply u ux plus v vx equal to 0, which I have written here. Okay, and since the same thing hold for the variable y, we will have this. Okay, now you can use the Cauchy-Riemann equation. See, this ux this ux you can replace it by vy, right? Del u by del x is same as del v by del y because f is holomorphic. So Cauchy-Riemann equation holds. And this del u by del y, it is same as minus of del v by del x. Minus is here. So hence this holds. Now if you multiply the left equation by u and the right equation by v and add them up. So what I want to say, so these equation are nothing but u vy plus v vx equal to 0 and minus u vx plus v vy equal to 0. Now you multiply this equation by u and this by v. What will you get? So this will cancel out and you will get u square vy plus v square vy, right, equal to 0. So this is precisely this equation. Now there are two possibilities. If u square plus v square equal to 0, okay, then u, because it is a square, I mean it is square sum of two square numbers, so then u is 0, v is 0, because then it will imply u is 0, v is 0, and f is u plus iota v, so f has to be 0. Hence f is const through, hence f is 0. Is this clear up until now? Now if u square plus v square is not 0, then this del v by del y equal to 0, and from the, which also gives del v by del x equal to 0. You do the same algebra, and by Cauchy-Riemann equation you'll have the derivative to be 0, and if derivative is 0 then f is constant, right? So this you can try by yourself. Now the fourth part you check, this is the given function, and it they are asking whether at z equal to 0 Cauchy-Riemann equation holds. Now what is u? Uxy, u is xy, I mean, okay, for Cauchy-Riemann equation uxy is given to be xy and vxy is 0, right? So what is the partial derivative with respect to x? It is y. What is the partial derivative of u with respect to y? It is x. And because v is 0, everything is 0 for vx and vy. Now you know these two Cauchy-Riemann equation holds if and only if x and y equal to 0, right? So this option is true. Now this same function, is this holomorphic on unit disk? The answer is no. Why? Because it is real. If z has only real or imaginary part, then f prime z is equal to 0 or derivative. Just a minute, some doubt has come. Let me address that. Okay, let me finish this question, then I'll take the doubts. So, is this function holomorphic? X plus iota y goes to xy on the unit disk, which is a domain. So, is this function real valued? I guess this function is real valued, right? Because x is real, y is real, so their product will be real. And if, since this f is real valued on the unit disk, So if f is to be holomorphic, then we know that the only holomorphic real valued function we just proved is the constant function. But clearly this x times y is not constant, right? So hence this option is false. Now, yes, what are you asking? If fz has only real or imaginary parts, then f prime z is 0 or derivative exists at z equal to 0. See, if f has only real or imaginary part, what does this mean? Let's say if f has only real part, which means f is real valued. Obviously, we're talking in the setting of holomorphic function. So if a holomorphic function has only real part, this means it is real valued. This means it has to be constant, right? And hence in that case derivative will automatically be 0. Thangeshwaran, does that answer your question? uh, Thangeshwaran, you have asked this question: if f has only real or imaginary parts, then f prime z is 0 or derivative exists at z equal to 0. You have not satisfied, you have not assumed any
Derivative
conditions.
exists only at zero, sir.
Huh?
R
Sorry.
derivative is equal to zero.
If no, but
What?
what are the conditions on f? Are we taking holomorphic functions?
Uh,
Okay, let's assume, because we are in the setting of complex analysis and we all are learning the holomorphic functions. So let's assume we are talking about only holomorphic function. So if now the question becomes, if a holomorphic function has only real or imaginary part, then what happens, right?
yes, sir. Yes, sir.
Now, if it has real part, if a holomorphic function has real part only, which means its imaginary part is 0, right? So it is real valued, right?
Yes, sir.
So it will be constant. Now come back to the second case. If f has imaginary part, if f has only imaginary part, which means it is some iota v, where u is 0, because, right? Now you multiply it by iota f will be minus v. So this iota f, this is again a holomorphic function because f was holomorphic, but this time it is real valued holomorphic function. So iota f has to be constant. So f has to be constant, right?
Yes, sir.
Okay. Yeah.
Okay, sir.
Yeah. So the sixth question, the last question. Now, which of the following statements are true? The function ez bar bar, I mean, you take z bar and then you take again 1 bar. Is this entire? So, if you remember, ez has a power series, right? 1 plus z square by 2 factorial, blah blah blah, right? Now, when you take replace z by z bar, what does it become? This become this. Am I correct? Does this make sense? Now, when you take one more bar, it becomes this. And eventually it will become ez plus z square by 2 factorial and something something something. So this is precisely e of z only. Am I correct? Do you follow this, students? Okay, so ez is entire function, so hence this function is entire. And anyway, we'll see much general result in part 5. Okay, so in this question we'll use power series very much. Okay, now second question is, if conjugate of sine of conjugate z is minus of sine z, this is possible if and only if sine z is sine z bar is equal to 0. Okay. Now you know that the power series expansion of sine z is this. Only odd terms survive. odd terms means only those coefficients survive which are the coefficients of z power odd integers or odd natural numbers. Okay, so again we use this same thing. If you replace everything by z bar, so you will have bar here, right? And then you take the whole bar, so this will become sin z again, right? Because this is bar, then this is bar. And because coefficients are real, one thing you have to observe, that coefficients are not changing because they are real. So this will again become sin z. Is this clear? So which gives that sin z bar, bar is sin z. So hence now you use this condition. So this bar of sin z bar is minus sin z, if and only if sin z is minus sin z, right? Now when is sin z equal to minus sin z? Hello, am I audible? Please just confirm, because I think my network went off. I just want to confirm, am I audible? Hello.
Yes, sir. Yes.
Yeah, okay. So sin z is minus sin z. When is it possible? This is possible if and only if sin z is 0, right? But when sin z is 0, sin z bar is automatically 0, right? Because if z is the root of a function, z bar is also a root. I mean for sin z, not for any function, for sin z. From you also you can check here, because sin z is because all of these are if and only if. So this first condition, what does it imply? Sin z is 0, so sin z bar will be 0, but you take one conjugate again, so it will be sin z bar is 0. So is this part clear? Now same thing we can do using the power series for. So this says cos z is 0 if and only if cos z bar is 0. So I have written down two proof, but the simpler, you can check this identity, but I want you to use the power series expansion because it is simple to see. Again, when you take bar, okay, when you take the bar and you take one more bar, so it will be cos z, right? It will be cos z. So we'll have cos z bar is cos z, which is okay. And this I mean this is same as saying that cos z bar is same as cos of z of bar. You take one, I mean you take one more conjugate. So if cos z is 0, when is it 0? If and only if its conjugate is also 0, right? But from here we know the conjugate turns, this is same as saying cos z bar is 0. So is this clear? Yeah. So you please use the power series expansion. Now, okay. If p is a non-constant polynomial, okay, so p is a polynomial, okay, and it says that p of e z bar is p of ez. Does this always hold for every z in C? This is not true, right? Because if you take pz equal to iota, and let if this holds, let this holds, then at z equal to 0, what should it be? P of e0 bar should be p of e0, because 0 bar is 0. So this implies E0 is 1. So P of 1 bar should be P of 1. But here what is P of 1 bar? It is minus iota, right? And it is iota. So this is not correct. And the fifth question is same as what we are doing. So see, this is called something, you might learn in the due course. It is called reflection. Okay. So if you have an analytic function, if you have an entire function, there is one way to construct an entire function, and it is same as this. You take bar and then you again reflect. Okay. So if you're now, we have to prove that this new function gz is entire. So because f is entire, it can be written as this, right? Then you take, if you replace z by z bar, it will become this. Let me just, yeah. And then you take one more bar, it will become this. So finally, it will be a naught bar plus summation an bar zn. Okay. And this is precisely what I have written down. Okay. So this series, so entire functions have, a function is entire if and only if it has a power series for the entire complex plane. So we have come up with some power series. Okay. Now we have to check what is the radius of convergence. So we know that radius of convergence of G by the formula, it is lim, uh, there is one more formula, lim sup mod a, because the coefficients are a and bar. Okay. 1 upon this. But we know mod of z bar is same as mod z. So this won't change, right? We can replace a mod a naught bar by mod an. And this is nothing but radius of convergence of f, which is infinity because f is an entire function. So hence G, this series converges everywhere. So which implies G is entire. Okay. So with this, we finish our third assignment. So if you have any doubt, then please ask. E bar Z not entire, correct? Okay, what are you saying? E Z bar. No, it is not entire. Because you see, if you have learned, like this function will not even satisfy Cauchy-Riemann equation. As long as you have Z bar in the variable, that function will not be analytic. We can check. If you want, we can check. Okay, let's check. Okay, it is Ex minus iota y, right? So this is Ex E minus iota y, which is Ex cos y minus iota Ex sin y. Now, if this function is entire, Thangeshwaran, then, so this is my u and this is my v. V is this minus, okay? So what is ux? Ux is Ex cos y, right? What is my uy? Uy will be minus Ex sin y. What is Vx? Vx will be minus Ex sin y. And Vy should be minus Ex cos y. So for Cauchy-Riemann equation, Ux should be Vy, right? So Ex cos y minus Ex cos y, which will imply Ex, because Ex is never 0, so this is 0. But this implies cos y is 0, because Ex is never 0. Never 0. So Cauchy-Riemann equation does not hold for any point. I mean, for only some discrete points. So hence it should not be entire, right? Is this clear, Thangeshwaran?
Yes, sir.
Yes,
Clear,
sir,
sir.
clear, sir.
Any other doubt in this assign? Okay, sir, I have a problem on week 1 assignment, question number 6. Okay. Is this assignment 2022? Okay. So I'll have to ask the instructor, because we are permitted to discuss assignment of the previous session, in the sense previous year. So all of the assignment that we discussed, they are of 2021. Okay. But so maybe I am writing my email ID. So if the instructor allows me, you can contact me via this mail ID. Who is this? Manik Bagui. Okay. So this is my mail ID. You can connect with me, or you can post better. Okay, better you post your doubt on the YouTube comment box, because that will be easier for me to see. So all of you know that whatever we discuss, this is posted on the YouTube channel, right? Do you know all of this? Do all of you know this? So yeah. Anyway, yeah. So there is one doubt, sir. If there is unit circle region instead of unit disk in the earlier problem, in which problem? In the fifth, Ravi, are we talking about the this fifth question? Fifth part of this. Uh, so first of all, Ravi, we talk of holomorphicity on a domain. Okay, and when we say, if let's say, so question of Ravi is this: if unit disk is replaced by unit circle. Now, first of all, what do we mean by holomorphicity on a set which is not open? Okay, circle is this. Now we say F is holomorphic if there is some open set, there is some open set containing this unit circle on which F is analytic. Okay, and even if the answer will be same, you see unit disk has no role. You replace it by any domain. Okay, this is a good question. Unit disk has no role in this question. It is just for the ease of like making question. You replace it by any domain. If f of z equal to x times y is never holomorphic. Is never holomorphic on any domain. Okay, Ravi, is this clear now? Okay. Is there any relation between Taylor series and power series? Yes. Yes, there is. What is power series expansion? Power series generally, how does power series come? Power series come via the Taylor series expansion. When we say that an analytic function has a power series representation, it is precisely we are saying that f has a Taylor series representation. There is no difference. Okay, this is what I want to say. There is no difference. The one thing is that I would like to point out, when we say that f has a every analytic function has a power series representation, then these coefficients are given. Okay, and they depend on f. And otherwise, there is literally no difference between Taylor series and power series for analytic functions, or for any class of functions for that matter. Yeah, please ask. Yeah, please, let's discuss. The assignment is over, but we can always discuss. Yes, if there are any more doubts, you people are welcome. So if you have no doubts, then we can end this session. And you have my mail ID, Manik. I guess Manik is the name. Yes. Which Okay, Manik, what you can do? You can send me the question and your solution. Okay, both of them. Please also send me the problem. Otherwise, how would I know? Okay. Yeah. Okay then. See you. So I'll wait for 5 minutes. Then I'll leave the meeting. I'll end this session. So those who want to leave, they can leave. Thank you, Ravi. Hope to see you again. Thangeshwaran, I really hope that you come in the next session also. Prakash, I'll be excited to see you again in the next session. Okay then. Let's. Sir, can you send your email again? Okay, okay, I can send. Uh, I hope Manik you have copied this because I am now leaving.